All right, this lesson is a direct continuation of the last lesson. Last lesson, we went over the slope-intercept form of like a line and the idea that we have different forms of the equation of a line, and then we had the vertex form for a quadratic and the standard form of a quadratic, and I took you in kind of laborious detail through the steps for how to graph a quadratic in standard form. But before I let you loose to try to do these on your own, I feel like it's beneficial to look at a couple more examples, to let me like do them and talk through them and look at some of the things that tend to hang students up. What are some of the mistakes you might make? And then you'll feel a lot more confident about doing them on your own. So I'm going to move a lot faster through the steps this time because we've gone through them once. If for whatever reason you have not seen the last video, you need to go back and watch that first. Do not try to jump in, like that's just not how math works, okay? So go back and watch the last video first. All right, so here are the steps, and they're barely fitting on the screen. Hopefully there's no issue when I play back the video for this. So the steps for graphing an equation in standard form, you're going to find the axis of symmetry, and there was a formula for that. So if you need to write it down again, it is x is equal to the opposite of b over 2a. Now, I'm going to do a little bit of sidelight over here. You do need to know that formula. You need to be able to know the formula for finding the axis of symmetry, but there's good news because you will actually not need to have this memorized, not on your test, not on your final, possibly not anywhere. I'm not familiar with the reference sheets for some of your standardized tests, but there is a very famous formula. I hate it, but my hating it doesn't change anything about it, called the quadratic formula. And we will cover this in a future lesson. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay? It was my geometry teacher that made me memorize that. And notice I stayed the opposite of b there as well. This formula is given to you on almost every single test you have to take. I know it's on the reference sheet for your final for this class. I will provide it because it's on the final for this class. I think you can find that on like the little reference pieces for like the SAT and so forth. So this is often a formula that you have access to. If you look at this piece of it, you will see the formula for the vertex. It's like the quadratic formula, but without the messy square root part, but we don't like that part anyway. So if you're aware of that, you can actually look up the vertex formula and you don't have to have it memorized, but you do need to know enough about it to know that it is part of the quadratic formula. So that's like good news for you. So let's actually go and do a problem over here. Let's put the coordinate grid up. And the second example that I had, actually, what did I do there? I created two, I'm like counting the pages on, let's do like lined paper. I'll make it look like a notebook. All right, so this is example 2. And the problem is y equals 2x squared plus 8x plus 1. And so the first step is to find the axis of symmetry. Then I will have my formula, the opposite of b over 2a. And we want to look very carefully. A is 2, B is 8, and C is 1. I just said that caution again. They usually go from left to right, but not always. So A is the number in front of the x squared, B is the number in front of the x, and C is the number by itself. If you do not see an x or a number by itself, it means that the value is 0. Okay, if you don't see an x squared, it's not a quadratic, so that like changes the whole ball game. Okay, if you see just an x or just an x squared, it means the coefficient was 1. So the opposite of b, well, b is 8, so the opposite of 8 would be negative 8 over 2 times a, but a is 2. And then make sure that you are using order of operations, so 2 times 2 is 4. And negative 8 divided by 4 is negative 2. And then I will come to my graph, I will count over x is -2, and I'm going to do a dashed vertical line right on where x is equal to -2. And it's dashed because that's not part of the parabola. It's just something that we're going to use to graph our parabola. All right, next step is to find the vertex. But remember, like there are key things here, okay? Remember that the vertex is on the axis of symmetry, which means we already know the x-coordinate of the vertex. The x-coordinate is going to be -2. And so just as a recall, plug x into the function. That's how you've got your x value. You already have the x value of the vertex. So you're going to go ahead and plug that in. So we would have y equals 2 times -2 squared plus 8 times -2 plus 1. Depending on your model of calculator, you might be able to just dump that in exactly as is with the parentheses, with the negatives. Most scientific calculators, except for like the very most basic scientific calculators, you can enter that entire thing in. And that's beautiful because that means you don't have to worry about positives and negatives and order of operations or anything like that. I do not have a calculator to demo on in this program, so I will go ahead and do. Now, remember your order of operations, okay? I'm going to put them up here. PE, and then M and D go together left to right, and then A and S go together left from right. You have to do the exponent before you do the multiplication, okay? So right here, you have multiplication. Right here, you have an exponent. You have to do the exponent before you do the multiplication. I will repeat that. You have to do the exponent before you do the multiplication. That's your order of operations. So the first thing I'm going to do here is do -2 squared, which is -2 times -2, which is +4. Now I have some multiplication to do. So I'm going to do 2 times 4 is 8. 8 times -2 is -16. And then my adding and subtracting go from left to right. When I always write it, I write like a little slash between the AS to indicate that it's actually the same thing, because like subtraction is just adding a negative. And so if you pulled what my Algebra 1 teacher said to do, which is instead of writing -16, you do plus -16. Now it becomes very obvious that you're going to do it from left to right, because that's all subtraction is anyway. So we have -8 plus 1, which is -7. So the vertex is the point -2, -7. We had the x-coordinate, and now we found the y-coordinate to go with that. So I'm going to go over 2 and then down 1, 2, 3, 4, 5, 6, 7. And there's my vertex. Okay. Step 3. Find the y-intercept. Now, to find the y-intercept, you plug in x is 0. But please note what happens when I plug in x is 0. I end up with 2 times 0 squared, which is 0, and 8 times 0, which is 0, and I will be left with just the 1. And so the shortcut on that is that it will always be, your C value. If you don't see a value for C, it means it's the origin, okay? It means C is 0. And so in this example, the y-intercept is going to be 1, or if we channel Miss Braswell, the point 0, 1. So it's going to be right there. Next step is to reflect over the axis of symmetry, because the axis of symmetry is that mirror line. So if I have a point here, there's going to be another point over here on the other side of the axis of symmetry. And then my last step is to draw a smooth curve. So at this point, you've got your vertex, so you know where it turns around. You've got your y-intercept. You know that there's another mirror point on the other side. And so we will draw the best curve that we can. And let's talk a little bit about the curve before we go on and do the last example. First of all, it has to, things that are not acceptable, okay? And I think I did this in one of the other lessons when we were sketching graphs, but it probably bears repeating, okay? Here are things that you can't do, okay? You cannot make the sides of your parabola vertical, okay? Because that's not a function anymore. Okay, they are not vertical. Now, they do get very, very, very steep. But what I'm talking about is when students get over to the line and they intentionally stay right on that line. Like it's not an accident. Like this is how they're drawing the parabola with the vertical line. It's not vertical. It's going to continue to move out. So you cannot do that. The other thing you can't do is make it pointy. Okay, so no point. And the reason for that is because that is a different family of functions. That's the absolute value family of functions. So if you draw it pointy, then it's the wrong family. Now, if at any point you're not sure whether or not your graph or your sketch looks exactly like what it needs to look like in order to get full credit for something, you can always ask. You can even ask that during a test. There's a spot on the test, I think, where you can write a note to me and then send me a quick email and say, Miss Taylor, I have just a question about my graph. I want to know if it's, violating any of the rules for the graph. And I will respond to that. That's not a big deal. Okay. And there's our sketch for a parabola. All right, let's do one more. For this one, we are going to do f of x is equal to negative x squared minus 8x minus 8. Okay, so let's start by making sure we know what a, b, and c are. You can tell that this is negative out here, but remember, if you don't see a number, it is a 1. So our a value there is negative 1. Our b value is negative 8, and our c value is negative 8. Make sure that you slow yourself down and take the time to do that. Step number 1, and you should have these steps written down yourself. Find the axis of symmetry. We have a formula for it. So the formula for that is x is equal to the opposite of b over 2a. The opposite of negative 8 is positive 8 over 2 times negative 1. So that's 8 divided by negative 2, or x is equal to negative 4. When you are writing the axis of symmetry, you must tell me x equals negative 4. On the activities from Friday, that was something that I was writing on some of the PowerPoints, because you guys were just saying axis of symmetry is negative 4. It is a vertical line at x equals negative 4. So you do need to say x equals negative 4. So that's just like a heads up. 1, 2, 3, 4. And let's go. And we're just doing this. We're using this as the mirror line, and that's why we make it dashed. Step number 2, find the vertex. You already have half of it, so you're going to plug x into the function. So we have y is equal to negative 4 squared minus 8 times negative 4 minus 8. I'm going to wait for a few seconds and let you guys write that down. Now, be careful here. And I want to go through, now that you've had a chance to write that down, to actually explain what we're looking at so that you don't lose any of the pieces along the way. There is a negative that is right in front of the x squared, okay? This negative is that negative right there, okay? If you took your eyes off the screen for a second, I'm going to go back and redo it. This negative is this negative right here. This negative is coming from the x, okay? So x itself is negative. So this negative on the 4 is this one right here. And I'll do it again. I know I'm slowing down, but this is a real sticky point for people, okay? The negative in front of the x squared is this one right here. The negative in front of the 4 is this one right here, and you need to have both of the negatives there. Now, you also need to remember your order of operations. This squaring comes first. So negative 4 times negative 4 is positive 16. I will let you write it down, and then I'm going to say it again. Negative 4 times negative 4 is positive 16. This negative right here is still there, and it's going to come down. And I'm pausing. I know it's like kind of awkward, but I'm pausing in order to let your brain digest where all these negatives are coming from and then where they're going, because it should make sense. It's not like voodoo math where negatives appear and disappear. Okay, so this negative, when you square the negative 4, it becomes positive 16. This negative is still here, and it comes down. That's the real sticky part. Now, this part we have, remember my Algebra 1 teacher would make me write plus negative. So we'd have negative 8 times negative 4, which is positive 32. And then we bring down the minus 8. We are going to go from left to right. So negative 16 plus 32 is positive 16. And then 16 minus 8 is 8. So the vertex is at the point negative 4, 8. And I'll wait a moment for you guys to write that down. And then I'll come back over here and let's go plot this. I'll change the color up over here. So it's negative 4, and then I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. All right. Now the rest of this, there's actually nothing much. There's like, we're done with the work. It should be really smooth sailing from here. Find that y-intercept, but remember the y-intercept is always going to be your c value. And so, whoops. In this case, my c value is negative 8. And so we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, almost down to the bottom. 1, 2, 5, 6, 7, 8 right here. Okay, and now the next step is to mirror or reflect that over the axis of symmetry, and then we'll draw our smooth curve. So this is 1, 2, 3, 4 units away. So I'm going to go 1, 2, 3, 4 units away. And then I'll just change the color up like one more time. And then we're going to draw, whoa! What did I just do? I paused the video is what I did accidentally. Let's try that again. I'm trying to grab stuff at the bottom of the screen, and so I accidentally like pulled up my iPad menu and paused the video. All right, now let's like go through and just do a quick summary of some of the stuff that we know about transformations. First of all, on this one here, we know that multiplying by a number makes the graph skinny. And if you look at the graph, not for that one, I went the wrong way. For this one, it is skinnier than the other graphs that we've done. We also know that a negative out in front flips the graph over. And if you look at this, indeed, the graph was flipped over. So there were some consistencies with that. So that was basically just a couple more example problems to reinforce the steps and to really talk about some of the things that tend to trip students up on that, so that I'm not sending you out to just do problems without having like enough background. So there are 2 practice problems that I would like you to do. The first one is I'd like you to sketch the graphs for these. F of x is equal to x squared minus 6x plus 4. And the second one is negative 3x squared minus 6x plus 1. And notice I am continuing to try to like change the notation up. So depending on how and when you are doing this lesson, this is probably the end of it. If you're watching it on your own, pause the video, do that workout, and I will do the workout very quickly as a review and a check for your practice work. Okay, so for this first one, I'm going to do this much quicker so you'll get a sense of the actual pace of this. Step number one is to find the axis of symmetry. The formula for that is the opposite of b over 2a. I want to make sure I understand that my a is 1, my b is -6, and my c value is 4. The opposite of -6 is +6 over 2 times 1, which is 2. And 6 divided by 2 is 3. So I will come over here to x is, I can't remember what I had. X is 3. 1, 2, 3. And I will do a dashed line here where I know my axis of symmetry will be. Step number 2 is to find the vertex. And to find the vertex, I will simply plug in the 3. I would counsel you to always put parentheses there. That's just, I mean, I don't, but then I'm a lot more confident on when I can put them and when not to put them. So we end up with -9 equals -9 plus 4, and so the vertex is at 3, -5. And so over here, I will go 3, 1, 2, 3, 4, 5, and there's my vertex. Step number 3 is to find the y-intercept, but the y-intercept is always your c value. And so the y-intercept for this is going to be 0, 4. And so 1, 2, 3, 4. Now I will mirror that over the line of symmetry. So I'm 1, 2, 3 units away. I'll go 1, 2, 3 units away on the other side. And then my last step is to just draw the smoothest curve that I can. It doesn't have to be perfect. And so your final answer should look like that. And notice that that took me in the vicinity of about 2.5 minutes to do, as opposed to like 10 minutes when I'm explaining the steps out and really going over them. All right, let's look at the next one. This one is, we have, what do we have here? Y equals -3x squared minus 6x plus 1. So step number 1 is to find the axis of symmetry. That's going to be the opposite of b over 2a. And let's just do a quick check over here. A is -3, b is -6, and c is 1. So the opposite of -6 would be +6. Over 2 times -3. So this would be +6 over -6, or x is -1. I will go over to x is -1, and I will do my dashed line there so that I know where that axis of symmetry will be. Step number 2 is to find the vertex, which means that I'm going to take the x is -1 and plug it in everywhere I have an x. And watch your order of operations here. -3 comes down. -1 times -1 is +1. Then multiplying this through, I get -3. A negative times a negative is going to give me a positive. And then -3 plus 6 is 3, and 3 plus 1 is 4. So the vertex is -1, 4. And I will come over here and plot that. Let me change my color. There we go. There's my vertex. Next step is to find the y-intercept, but remember the y-intercept is always your c value, because you're going to plug in the 0 and everything else cancels out. So we end up with 0, 1. And then I will mirror that same distance away over on the other side. It's going to be a very skinny parabola, and that shouldn't surprise you that it's going to be skinny and flipped over because of the -3. And then I do a smooth curve. And that one, again, took me in the vicinity of 2 to 2.5 minutes to do. So one of the things you need to work on is just getting experience to build up your speed with these so that you are not taking, 10, 15 minutes. The last test, there was a lot of drama about I didn't have enough time. Well, part of that is you didn't do enough practice work to build up your speed. And by the time you get to the test, you can't take, 15 minutes, 10, 15 minutes to graph one parabola. You do need to move faster than that. All right, well, this is the end of the second lesson, and we will work on some practice work.